Dear all, I welcome you to the first introductory video lecture of EEE 615 Microcontroller Architecture and Organization. In this video lecture, we are going to learn about a tool called Keil Microvision. The version that will be used for the demo is 4. Okay, this is an integrated development environment which supports various processors and platforms for us to write our programs and program the respective hardware or microcontroller. This is an integrated development environment, shortly called as IDE, based on Eclipse platform. What is this integrated development environment? Earlier, one used to write the program in a separate text editor, save it as .asm or .c, go to the command prompt. That is, you have to switch window, go to the command prompt, compile it there. In case there are any errors, quit the command prompt, come back to the text editor, correct your program there. And what you have to do is again go back to the command prompt, compile it. Upon successful compilation, run the program in the command prompt. Whereas after the IDEs came into existence, you see everything is available in one single package. We can view the project hierarchy here. You can have your text editor or the program editor here. You can compile it. You can see the compilation. Everything. I mean, you can run debug. Okay, everything can be done under the same window or same head. So that's why we call it as IDE. So first, let us look at the aspects, different aspects of this Microvision 4. First tag, what we see is the file here. So this is where you create your new text editor. You see, so this is where you write your programs and save it as .asm or .c or .c++, depending upon what kind of projects you want to develop. So this file tag is responsible for opening a new file, creating a new file, opening a new file, save. Okay, and this is the device database, which will tell you, what are the different devices supported by the Keil. You see, a lot of families are here, different families. Mostly for the introductory classes, we'll be using this Atmel family, especially 89C51. This is the platform that we'll be working on in the initial stages of this course. So this device database will tell you what are the different platforms or devices supported by this Microvision 4 version. Okay, then edit, view, these are all the regular tab items that you will see in any tool for that matter. The next tab is the project tab. This is where you create new project, open projects, you select a device for your project, so many things. We'll see it one by one. This flash utility is once you generate your executable, that is in this case a .hex file, using this flash command, we can download it or configure the hardware. And this debug tab is generally for starting or stopping the debug session. When I say starting or stopping the debug session, only when you get into the debug session, you can run your program completely or step by step, or check whether everything is working fine. In case there is any error, to check where the error is, you can set breakpoints, remove breakpoints. All these things happen under this debug window. Under this peripheral, since now no project is active, you can't see anything. But under the peripherals window, what are the things that are visible? Depending upon the hardware and platform you choose, the different ports available in that microcontroller, or different, I2C bus or SPI bus or timers that are present in the microcontroller will be visible under these peripherals. So at any point of time when the program is running, you can click to see what changes are actually happening inside those peripherals. Okay, and these are some of the tools that can be used or integrated along with Microvision 4. And these are the several windows that you can see, and always, as usual in any tool, what you see, this is the help menu. Okay, and these are the shortcuts. I mean, either you can go here and create a new file, or directly click on this to create a new file. Okay, this is the compile button, build button. Okay, which ultimately generates the executable for you to run the code either in simulation or targeting it to the hardware. So these are the several shortcuts that are available for you. So either you can access them by going to this menu, or you can access them by using these shortcuts. Now let us slowly see how to create a project, how to create a file, how to add a file to the project, how to run, where to see the results. Okay, so I'm going to create a new project. So I'm going to the project tab, and I'm saying I'm going to create a new Microvision project. So it opens up a window where you can save. So I'm going to create a new folder and call it as sample project 2. Okay, so I'm going to go in, So I'm going to say give the name of the project here as project 2. Okay, it automatically names it as the extension, so you don't have to worry about it. So just name the project. Why actually I'm creating a separate folder to save this project is when you compile this, when you build this, there are a lot of accessory files that are created along with this. So if you do it in a common environment, you may not able to identify like which file belongs to what, because all of it will carry the similar kind of extension. So it's always a good practice to save a particular project in a separate folder, so all the files associated with the project will be available inside that folder. It will be easy for you to check whether it has been created or not, whether it is available or not. Okay, so by saying save, I have created a project. So once you create a project, okay, the tool will ask for what kind of target hardware you want to choose, that is what kind of microcontroller you want to choose. There are several options available for you. It can be either Norton M0 database or generic. So to start with, let's go for generic CPU database. So once I click OK, you see these are the various devices supported by this particular version of Keil. So many vendors. Okay, if you look under each vendor, you can see so many chips, processors or controllers supported. Okay, as I told you, to make things simple, we are going to start with Atmel 89C51 because that's one of the most basic microcontrollers what one can easily understand. So 89C51 is what I'm going to choose. 89C51. So this description is nothing but the device description. Okay, it has got 32 IO lines, it has got 2 timers, counters, 6 interrupts, 2 priority levels, it has got 1 UART, 4 kilobytes of flash memory and 128 bytes of on-chip RAM. Okay, so once I pick the device, I click OK. So once I click OK, it will ask for something like copy startup.a51. If you are planning to write a assembly level program, this is not at all required for your project. Whereas if you are planning to write a C program, this is required. So first I'm going to teach you how to write an assembly level program. So I'm going to say no. For assembly level programming, this is not required. You don't have to say yes, but for a C level programming, you have to say yes. So since I'm going to start with assembly level, I'm going to say no. You see now the project is created with a target in place. Okay, now when I expand this, you will see no files are being added. Okay, so now I'm going to create a new program and then add it to the target. Okay, now let us not worry about how to write a code, how to write the assembly level language, because the aim of this particular video lecture is to show you how to create a file, how to create a project, how to add it to project, how to compile, where to see the results as far as the tool is concerned. In the next video lecture, I'll detail you on the assembly level language instructions, which instruction is used for what purpose and how to write them. Okay, so I'm creating a new file by clicking this particular icon. Now I'm going to start writing the program. Okay, thus I have completed writing my program. This is a simple assembly level program to add 2 numbers. Okay, now you see there is nothing highlighted here because the IDE doesn't know what kind of a file it is. So I'm going to save this file. Where am I going to save this file? You see, remember I created a folder called sample project 2 inside which I have saved this file. Same folder you have to save this file as well. I'm going to call it program1.asm. Because it's an assembly level language, I'm calling it as program1.asm. Now I have saved. See, once I save it as ASM, you see all the keywords are highlighted with color, blue color. So that indicates your keywords are correct and my program is right. No issues for that matter, syntax wise. Now I have to add this to this project. There are 2 ways of doing it. How? You highlight the source group, right click it, and then you say add existing files. Okay, add existing files to the source group. Okay, it will take you to the sample project 2 folder where you have created it automatically. We are looking for ASM. Since by default it shows C source files, you don't find anything on this window. I'm going to say ASM file. You see my program here. So what I do is I click program 1 and simply say add. And then once I click add, you see a plus symbol appears here indicating that the file has been added. Now I say close. Now if I drop this down, you see this program has been already added. Okay, in case of a single file which needs to be added like this procedure is fine. Okay, I'll show you another method where if you want to add a bulk of or a set of files, if you start adding one by one, it's going to consume time. So I'm going to teach you another method of how to add. Now this file has been added. Now I'm going to remove. How to remove? Right click, remove file. Right click and remove file. It will ask you for the confirmation. Once you say see, now the file has been removed and the expansion symbol, the plus symbol is gone here. Now what is the other way to add? The other way to add is very simple. Do you see a 3 colored block here? Okay, this is where we can add. So you click on this. The moment you click on this, it will say target 1, source group, and this is the part where we add files. So when you say add files, the same window appears here, whatever we did by right clicking. Now the beauty here is once I select ASM, the same program appears here. I can add. Still the window is open. If you want to add any other file, you can press Control, keep clicking that file and add 3 or 4 files or even 10-15 files together. Now that I have added this file, I say OK. The moment I say OK, you see this file is added to the source group. Now I have added to the file. Only after adding your program file to the project, you will be able to build or compile or do whatever. If you are not going to add the file, it'll say source not found, or you'll be getting error, or you'll not be able to successfully compile your project and download to the hardware. Now that I have added the file, I'm going to assemble it. See, now I have assembled. My entire syntax is correct. It says at the bottom of the window 0 errors, 0 warning. So I don't have any warning or error. Now I have assembled it perfectly. I'm going to build it. Again, after I build it, I'm getting 0 errors, 0 warnings. Okay. Now again see 0 errors, 0 warnings. Now it's time for me to run my program and see the output. Okay. So how do I run my program? So what you have to do is, before you run your program, you have to tell the IDE whether you want to run it in the simulation mode or emulation mode. What is the difference between simulation and emulation? There are 3 ways of executing your program. One is simulation, one is emulation, third one is standalone. So what is simulation? Simulation is you don't require any actual hardware. Okay, the hardware environment is simulated within this tool and it will give you the results. That is called simulation. What is emulation? Emulation is you have a physical hardware connected to your computer. Still the hardware cannot run on its own. It will be controlled by your computer or the tool. So that is called emulation. What is standalone? You dump your code or you burn your code into the hardware, and all you have to do is let the hardware powered up and it will run by itself. It doesn't need any other support from the computer or any other host device. That is standalone. Okay, so before we start running our program, we have to tell the IDE in what mode we are going to run. So for that, what you do is you go to this project tab. Okay, you go to the project tab. You see something here called options for target. That is where you specify everything. So what you do there is you click options for target. So when you go to the options for target, the first tab is device that we have already selected it as 89C51, right? So when you go to the target, it is asking for, you see something here, extal megahertz. This is nothing but the clock. See, every digital device needs a clock to run. So this is where we say at what clock speed are we going to run our hardware in. Depending upon the board you choose, depending upon the hardware environment you use, this clock speed is going to vary from board to board. Okay, the ones we have in our lab runs at a speed of 11.50592 megahertz. So that is why I'm inputting that particular number, 11.50592. Okay, so once that is done, I'm coming to the output. This is where you say create hex file, so that once this hex file is created, it can be downloaded to the board. Okay, and finally you come to the debug. This is where you say in the debug window whether you are going to simulate or you are going to emulate. Okay, first let us see how to simulate, and once we are thorough with this, we do a couple of exercises on simulation, then we can go for emulation. I'll take you to the lab and experience the emulation part. So I'm going to simulate. Okay, so I'm going to simulate. I'm not using a run program. Sorry, I'm not using a C program, so this doesn't matter. This doesn't matter. I can leave it as such. I can remove this check symbol because it's going to be an assembly level program. So once I say simulation, I say OK. Now the simulation environment is set. Now I can run my program either by going to debug, start, stop debug session. Either I can click here, or you see the same symbol is being displayed here. I can also click here. So let me click this. Once I click this, see, actually there are two versions of Keil. One is called professional version and one is called student version. The student version is available for free for you to download, and the professional version you have to pay a license fee. The only difference between a student version and a professional version is, in student version you cannot write any code greater than the limit of 2K. It is restricted to a code size of 2K. In professional version, the code size doesn't matter. You can write any big programs, okay? But for your laboratory purpose and the scope of this course, this is more than sufficient. So I say okay. Now if you see, the entire window changes from your project window to the debug window. This environment, what we see here, is called the debugging window. Now if you see here, there are various registers. REGS stands for registers. So various registers that are mentioned here. You see, even in my program I have used a register called R1. So this is where you see the output as far as this particular program is concerned. So these are the various registers present in the device what I have chosen. This is accumulator. A stands for accumulator, B stands for, and there are two accumulators. Okay, so this is the program counter value, this is the DPTR, that is data pointer. These are several status registers which we can see or use, to actually see our results and run our program. Okay, now I'm going to tell you or show you how to run and see the results. For understanding purpose, I'm not going to run in a single. See, this particular icon here is for running it in one single step, whereas the icon here is for running it step by step. Initially, I'm going to use this to show you the change. You see, now everything is 0, 0, reset to 0. Everything is 0. Now what I'm going to do is I'm going to run my program for the first time. When I run my program, see what happens. I'm moving the number 5 to the accumulator A. Move is the opcode. We call it as opcode. Okay. So this is the instruction which is asking the number 5 to be moved to the accumulator. So when that was executed, you see initially the A content was 0, now it has moved to 5. What is the next instruction? The next instruction is also move, where I am asking the program to move the number 2 to the register R1. So when I execute the next statement, if you watch R1, which is 0, 0, it will change to 2. Watch closely. See, now it has become 2. So I have moved the number 5 to the accumulator A, moved the number 2 to the register R1. Now what is the next statement here? I am asking the program to add, by using the instruction add, to add two numbers A and R1. The two numbers present in A and R1. So it is going to add 5 and 2, and the result is going to be stored in accumulator itself. So I'm going to go for the next step. Now this number 5 is supposed to change to what? 7. That's correct. Now you see this. It has changed to 7. These two numbers has been added and it has been saved in the accumulator itself. So this is how you run. Now if I want to reset everything, I just press the reset button here. Everything goes back. Everything goes back. Now I can run it in one single step, which will ultimately give me the result. But you wouldn't have seen those changes. So once you practice this and get familiar with this, you can use this button. For example, if you are going to use a loop, if you are going to use a step-in function, you will be doing it forever. There we require to use this particular run button, which will run it in a single step. Got it? So these are some of the various functionalities available with the Microvision 4 tool, which you can use to write your program, add your program to the project, create a project, set target parameters, tell the tool whether it is going to be simulation or emulation, at what speed you want to run, come, debug, run it stepwise or continuously run, see the results in the register and accumulator. There is more to this tool which cannot be explained in one single video. So on an ad hoc basis, as and when we proceed with several hands-on lab exercises, I will reveal in several video lectures the different aspects of this tool, how to operate on the memory window, how to see the results in the memory window and everything. Thank you. See you in the next video lecture.